So here's part B of this problem. So this time the cross sections are squares, and the thing that I want to try and do these a little bit more quickly, efficiently, the way you would do it on your homework. So the things to pay attention to is its cross sections, what are the cross sections, and perpendicular to which axis, because your two formulas are cross sections perpendicular to the x-axis or cross sections perpendicular to the y-axis. And the only difference between them is, are you integrating with respect to x or with respect to y? So when we have perpendicular to the x-axis, we're going to be integrating with respect to x. That's why it's on the dx side of the page. All right. So I find it helpful if you're going to, do this. I'll show in the next one. We can telegraph this probably even a little bit more. Like, you don't necessarily have to draw this 3D. You can draw it 2D. And then, the important thing is, what is the part of the figure that is in the region? So the region down here, and then the squares are going to stand up out of that region. That was an unfortunate choice of size because it runs into my axis. All right. So, in general, the squares look like this, standing up, and then so you don't have to draw this part. It's nice if you can, but that's sort of what it looks like that, and then it's got a flat top going across, right? A flat top going across, right, but you don't have to draw that. In fact, you really could just draw this with a sketch. For people who struggle with drawing, right? You can just draw, here's your curve, y equals 2 squared x, and here's my representative side of the square, and where is that square, that side and that square, so I have squares that look like that. And then I will know that I'm taking the square and I'm standing it up and putting it on there. So this is like the 2D version of the drawing. This is the 3D version of the drawing, either way. All right, so either one of those is fine. So now, what you have to do, say, next is, what is the area function? All right, so I have a square, so since I have squares, all right, the area is s squared. So you're going to start with, you need a formula that relates the part of the figure that is in the region. That's s. It's a, standing for a side. Okay, so area is s squared. Now I need an equation that describes s. I need s in terms of x, because this is perpendicular to the x-axis. Otherwise, I'll get s in terms of y. So you say, what is s? So if you look on the 2D drawing especially, right, here's your curve y equals 2 square root sine x. Here, down here on the floor, it's 0. So each segment, no matter where I draw this segment, it extends from the curve, which is y equals 2 square root sine x, to the x-axis, which is y equals 0. All right, so that means that s equals 2 square root sine x minus 0, and you don't have to write the minus 0, of course. All right, so that means that this a is going to be 2 square root sine x squared. And now I've got a in terms of x, and that's what I need. So I should try to simplify it. That is equal to 4 sine x. And then so my volume is going to be the integral of a of x dx. I need to think about the limits of integration. So this figure goes from 0 to pi. I can put that here. I can put that here. That's a little confusing. It means y equals 0. Let's get that out of there. All right, so I'm going from 0 to pi, and my x coordinates, because I'm doing dx. So that means that I have integral 0 to pi, and then I just take my a equals, you may put a of x, because the a depends on the x. So my a of x is 4 sine x dx, and then I do that integral, which is easy. By the way, since we now, like if you know the integral from 0 to pi of sine x is 2, look how easy it is to say this is 8. All right? Okay, so now let's do number 42. Okay, so now in 42, I've got this equation, x squared plus y squared equals 1, and the key here is that I'm doing, well, two keys here. One is that I'm doing isosceles right triangles, and the other is I'm doing perpendicular to the y-axis this time. So on a diagram like this, it's important to label your axis. I've noticed a lot of books tend to do really weird things, like having y coming down this way, like weird things. I always have y going this direction, x going that direction, just for consistency. Now, since our triangles are perpendicular to the y-axis, all that changes is we're going to put everything in terms of y. So that means we need to solve for x, right? Equation solved for x. All right. So perpendicular to y-axis means that these shapes are looking like this. All right, that's the side that's in there, and then you have right triangles coming up this way. And if you want sort of a fuller picture of what that looks like, it looks a little something like this. That's on page 408. All right, now, again, you can also draw this 2D if you want. So you can just draw your x squared plus y squared equals 1, which we all know is your unit circle. See, I can even do a terrible drawing of it. And then here's x and here's y, and we're doing perpendicular to the y-axis. We have this, and then what's my shape? It's this isosceles right triangle. So this is my side S in here. So these are, like, you don't have to do both of these drawings. This is a 2D version of the drawing, 3D version of the drawing. You know, pick one. All right. Now, so the next thing that we need is just a formula for the area. So, you know, what is the area of a isosceles right triangle in terms of this S? Well, if you think of a square, right, this is half of the square. So here's a square that's S squared. All right, and we've got half of it. All right, so it's 1/2 S squared. You can also do that using 45-90 triangle, but of course that's much easier to do it that way. All right, now, so now here's the tricky part, is what is the S this time? So it's easiest to see, I think, on this 2D drawing. It's going from here to here, all right? And so what we need is it's going from one side of this curve to the other side of this curve. So let's start with the fact that here's our equation, and we need to have it solved for x. So since the equation needs to be solved for x, I can say, let's use a blue for that. All right, I have to do x squared plus y squared equals 1. So x squared equals 1 minus y squared. So x equals plus or minus square root 1 minus y squared. And this is a great example of how the plus or minus is meaningful. And I put this, I think, in a couple of the homework problems. So this is the negative side of the curve over here. This is x equals negative 1 minus y squared. This is the positive side of this curve over here. This is x equals positive square root 1 minus y squared. All right? So where does this S begin and end? It begins at the positive square root 1 minus y squared and ends at the negative square root 1 minus y squared. So S is equal to this expression, square root 1 minus y squared, minus this expression, which is negative square root 1 minus y squared. That's what S is. From the right branch of the curve to the left branch of the curve. So the positive solution minus the negative solution. All right, so this really shows how this plus minus is really meaningful graphically. So of course here I'm just going to get 2 square root 1 minus y squared. All right, and then I can just plug that into here. So then I have area, the area depending on y is 1/2. So I have to put this 2 square root 1 minus y squared, so 2 square root 1 minus y squared squared, and that's the area depending on y. So by solving for x, I get something that depends on y, so I get the a of y that I need for this equation. All right, so then I just simplify that, so a of y equals, so this is going to give me a 4 times 1/2 is going to be 2, and then I have 1 minus y squared. Because the square and square root are going to cancel out. And so then I can say that the volume is equal to the integral from, okay, now the limits of integration now are going to be y coordinates. All right, so what are my maximum and minimum y coordinates on this figure? Well, it's a unit circle. It goes from -1 to 1. Let's put y equals 1, y equals -1. All right, so that means that the integrals from -1 to 1. And then I have 2 times 1 minus y squared dy. Probably use symmetry to simplify that because the lower half is going to be the same as the upper half. But it's not too hard to do. All right, so there's several examples of this last part of this sheet. Cross-sections perpendicular to x-axis, cross-sections perpendicular to y-axis. What do you have to do? You have to find an equation for whatever the area is, right? Find an equation for whatever the area is. and find an equation for area in terms of S, right? Then say what S is in terms of X or Y. Then put those together to get area in terms of X or Y, and then integrate that. All right, so that's what we did here too. All right, find an equation for the area, find an equation for the S, the side that's in the figure. All right, plug the S into the area formula, and then integrate it, X or Y. All right, find an equation for the area. Where did I put the equation for the area? Here, equation for the area. Find an equation for S. This one was tricky to get the S. Plug it in and integrate. All right, there you go. So with that, your final assignment on volumes, well, your final homework assignment is volume practice number 4. So now you got 4 volume practices to do, and you're also in a position that we can start talking about the volume project, which will be assigned next.